Welcome back to Chapter 6, Part 2, as we continue with using elimination to solve systems of equations. But now it's going to get a little trickier, but not too bad. Now when we use elimination, we won't know which variables will line up the same. So notice how we have a 3x and a 2x. Well, if we add them, they don't get to 0. If we subtract them, they don't get to 0. Looking at our y's. If we add them, will they get to 0? No. If we subtract them, no. So now what we have to do, we have to manipulate an equation to get at what we want. So this blue one, if I look at my 3y, I know if I multiply this 3y by 2, I get 6y. So that's exactly what I'm going to do. But now the catch is you can't do it to just the one variable. You have to do it to every single variable and every single number that is in that equation. So now the blue equation turns into 4x plus 6y equals 10. And I'm going to bring the first equation over here, so it's going to be 3x plus 6y equals 6. Now, how would I get my y's to cancel out? I am going to subtract. So I'm going to change both of these guys to subtraction because now I am subtracting. Adding up my x's, 3x minus 4x is a negative x. These guys are gone, equals a negative 4, so x equals positive 4. Once you solve for your x, now it's the same situation as finding your y as it was before. So let's go ahead and find our y. So I'm going to use the black equation. I'm going to plug the 4 in for that x. So it's going to be 3 times 4 plus 6y equals 6. We solve 12 plus 6y equals 6. 6y equals a negative 6. Y equals a negative 1. So again, our answers for this system is x equals negative 4 and y equals negative 1. I'm sorry, x equals 4 and y equals negative 1. Number 2. Now we look at our guys again. The x's won't match up, adding or subtracting. The y's won't match up, adding or subtracting. So now we have to do, can I multiply a 4 to become a 9? No. Can I multiply a 2 to become a 5? No, I can't. So now in this situation, what you have to do is find a common number that both of them will go to easily. So with this, I like just working with 5s and 2s. So how can I make this 2 become a multiple of a 5? Well, I know that if I multiply this first equation by 5, I get 10x plus 45y equals 15 if I take that 5 to every single number in the equation. Now, I'm looking just at my x's. How can I get this 5 to become a 10? I have to take it times 2. So I take everything in the blue equation times 2 to get 10x plus 8y equals 52. Now again, do I want to add or do I want to subtract? I want to subtract, so I'm going to change all these signs. I'm going to make them opposite. So if they're positive, I'm going to make them negative. If they're negative, I'm going to make them positive. So now we subtract 10x minus 10, gone. 45 minus 8 is 37. Y equals 15 minus 52 is a negative 37. So y is a negative 1. So there's part of my solution. Remember, we're looking for coordinate points. So now go ahead and plug it in. So I'm plugging it in to the top one. So it's going to be 2x plus 9. What was my y? My y was negative 1 equals 3. 2x minus 9 equals 3. 2x equals 12. X equals 6 for your final answer. Now we're going to be asked to determine the best method to solve each system of equations and then solve it. So we could use elimination or we could use substitution. Now when you use substitution, I would use it when you have something like this, y or x equals something, right? Y or X equals something. When you have that, you can just go ahead and plug it right in. So you notice on 3, Y equals 3X. Well, I'm going to take this 3X and plug it right in for Y because I know that's what Y equals. So I do that. I go 3X. And then from the rest of my black equation, X minus 6. Remember, the Y disappears when you sub it in, just like you would in football or basketball. So now I subtract my X. So now 2X equals a negative 6. Divide by 2, so X equals negative 3. Go ahead and plug that in. I'm going to just pick what I believe is the easier one. I'm just going to plug that negative 3 right in there. So Y equals 3 times negative 3. Y equals a negative 9. And there is our coordinate point for this system. Let's try a couple more. Now, when we use elimination, we have to look for variables that have the same number so we can cancel them out. So in this situation, here we notice that the y's are the same number. So if I use subtraction, they would cancel out. So I'm going to change, remember when you use subtraction, you change all of these signs. So positive goes to negative, negative goes to positive, and then this one is negative, so that one's going to be positive. So going down now, just like you're adding a 3-digit number, this is a negative 2x. This is gone, equals a positive 4. So x is negative 2. Now, with that, we can plug that in for any x, and I'm going to go back up to the top. You don't have to use the top equation. You can use the bottom equation, remember, but I just like using the top equation. So it's 3 times negative 2 plus 2y equals negative 4. Continue. Negative 6 plus 2y equals negative 4. 2y equals 2. Y equals 1. And so, again, we have our coordinate point. Finally, the last one. We won't solve it all the way, we'll just get it started, and then after that I believe that you guys are good enough with your skills that you can solve it by yourself. So let's take a look at number 5. Do we have y equals anything or x equals anything? No, we do not. So that really cancels out substitution. Can we now use elimination? Well, they don't really match up that well. So I would have to multiply both sides. But let's take a look at this bottom equation. Can I solve for a variable here? Can I perhaps solve for y? Well, let's try it. What would happen if I would subtract the 6x over to the other side? Well, then I would get 6y equals a negative 6x minus 6, yes? Now I can divide out that 6 off of y. So now we have y equals a negative x minus 1. Now I have y solved for. Now I can plug this in, the part that I'm squaring up in red, in for that y. So let's go ahead and do that. So from the equation I have 8x minus 5 times, and then what I put in squares, negative x minus 1, and then I close that up, equals 18. I keep going with this. I have 8x. Now it's a positive 5x, and a positive 5 equals 18. 13x plus 5 equals 18. I subtract the 5 over, so it's 13x equals 13. So we finally come up with x equals 1. So again, that is only part of our answer. How would you find the rest? You could plug that back in. Now, say you didn't realize that you could solve for a y or solve for an x. That is completely fine. Say you wanted to use elimination. Well, I like to work with 5s when I eliminate, so I would work with this guy. What would I have to multiply the bottom by? I would multiply the bottom by 5, and I'm going to write it over, actually I'm going to write it down here to make it turn into 30x plus 30y equals a negative 30. What would I have to multiply the top by? So is there a way that I can turn that 5 into a 30? Yes, there is. I would just have to multiply by 6. So I would come up with 48x minus 30y equals, and then 6 times 18 is a grand total of 108, I believe. And so now you could just go on from here. You could cancel those out, keep going, and then hopefully you would find out that x is still negative 1, or still 1. So you can do it both ways. You can solve for a variable, or you can eliminate. It's totally up to you. You should come up with the same answer. All right, finally, everybody's favorite word problem. So Tim has saved dimes and quarters in his piggy bank. Define the variables and write a system of equations to determine the number of dimes and quarters. Then solve the system using the best method for the situation. Well, what do we have? I'm going to define my variables. I have dimes and I have quarters. I'm going to let dimes be D, and I'm going to let quarters be Q. So what do we have? I have 25 coins. How do I get to 25 coins? I would just add up my dimes and quarters, right? So why don't we do that? How do we represent that in math? What represents dimes? Well, D represents dimes, so dimes plus, and then quarters Q. And how many do we have? We have 25. Now we also have $4. Well, how can we get to a money amount with dimes and quarters? Well, how much does a dime cost? A dime would cost 10 cents. We have to be careful. It's not worth 10, but it's 10 cents. So it's 10 over 100 or 0.1. And quarters would be 0.25. So now let's go ahead and make that equation. We go 0.10 what? 0.10 D, because it's a dime, plus 0.25, because we're talking about quarters now, equals, and just one normal 4. So now we have this equation and this equation. So now we can go ahead and solve. Now, could you solve for a variable here? Yes, absolutely. But I notice that if I multiply this guy by 4, I'm going to make a whole Q here. So I'm going to get 0.4D plus Q equals 16. And now we're ready to eliminate. So I'm going to bring this down just to make everything nice and neat. So it's D plus Q equals 25. Then it's 0.4D plus Q equals 16. I draw my line. I want to cancel out the Q, so I have to subtract. So I'm going to change all the signs. So now I have 0.6D equals, and that is 9. And so finally, D equals 15. Well, if I have 15 dimes, how many quarters do I have to have? Put it back in. So we have 15 plus Q equals 25. Q equals 10. So I have 10 quarters and I have 15 dimes. That together adds up to $4. And how many coins do I have? 25. And that does it for Chapter 6, Part 2. Good day.